Next one is instruction level parallelism. So in instruction level parallelism, we can refer to an architecture in which it's having the multiple operations can be performed parallelly in a particular process. Its own set of resources, address space, registers, identifiers, state, and a program counter. It refers to the computer design techniques and process to design to execute the operations. Its memory load, store, and integer additions, and the float execute the operations like memory load and store, integer additions, and float execute on multiplications. Its performance to the process. The example of architecture exploits instruction level parallelism and VLIWs superscalar architectures as having same execution hardware disk process, and it's having instruction level parallelism complex hardware to hardware implement of a multiple clock cycle operations to be pipelined. So here example is having some instruction. Here the operations are separated in operator operands, it's stored into the table. In architecture instructional parallelism, some multi operations are performed at cycle to executing the simultaneously parallel by the utility gaps, and it's having operations so created due to the latencies now. And the direction of when to execute the operations depends largely to that rather than the hardware. However, the extent to compiler to control the difference the type of parallelism architecture, whereas the instruction regarding the parallelisms to compiler hardware via the program varies. It's having the classification of instruction level parallelism, sequential architecture, dependency architecture, and dependency architecture. Sequential is not expected to explicitly convey any information regarding parallelism. It's a hardware, it's likely superscalar architecture. Dependency architecture, it's more mention the information regarding to dependency based upon operations data flow architecture. And then independent architecture, here the programmer gives the information regarding which the operations independent of each other's of instruction level parallelisms. So many instructions are like y on is equal to x1, it's having some certain address state likewise y2, and yx1 x2. X1 is y1 of addition of addresses, x2 is y2 of addition of addresses. You can add that temporary variables and increment the program content, store the data into another format. So these are all the instruction level parallelism in that computer architecture.